Okay, so now we're going to talk about an annuity. So an annuity is where you keep putting money in at regular intervals, and then it grows and it earns interest, and then you have, so much money at the end. Okay, so it's an annuity. It's periodic equal payments. And then we're going to want to know the total. Now, an annuity where you're earning money, we're going to want to know the total at the end, total amount of money, and how much interest was earned. Okay, so that kind of sets us up. So in the problem, in the example they give in the book, there's a couple and they're going to put in $50 every month for their kids' college. Okay, so they're putting in $50 every month. The annuity, the account, earns 6% interest, and it's compounded. That's APR, and it's compounded monthly. Okay, monthly. Anything else I need to tell you? Okay, and then how long are they going to do this? They're going to do it for 6 years. Okay, so the first thing we have to do, well, first of all, you might be saying, why isn't this just a compound interest formula like we've done in the past? Well, in the problems we've done in the past with compound interest, we put money in and then we walked away. We didn't put any more money in. We just let it sit there and earn the money over so much time at a certain rate. This, we keep putting more money in every month. So you don't have just an initial investment because you keep investing. Okay, so that's the difference. So the first thing you have to do, you have to deal with this right here. So if it's 6% APR, you have to divide that by 12 because you're compounding it monthly. So that's going to be 0.5%, okay? So what that means then is every month we're going to be multiplying by 1 plus 0.05, right? Okay, because you're going to have what you had at the beginning, plus you're going to be earning 5%. Okay, and then every month we'll know how much money is in the account. Okay, so this is going to be your R. Okay, so first month you have $50, and the next month you have 50, and then you're going to have plus, you have another 50 plus, 50 times 1.05. Yeah, okay. And then the next month, you're going to have 50 times 1.05 squared, like that. And then it's going to keep going, and it's going to only go for 6 terms, okay? I'm sorry, I take that back. It's for 6 years. Now remember, this is being compounded monthly. So this is like the first month, second month, and then eventually in third month, and then we want to add these up because we want to know, that's just telling you how much you had for that month, how much more you put in. But we want to total it up so we know how much is at the end, okay? So we need the sum formula. And let me put, this is not infinite, by the way, so S sub n, and it's going to be the first term times 1 minus r to the nth over 1 minus r. Okay, so that's the part that I always have trouble remembering. Okay, so now let's think about the different pieces here. Well, if we're doing it for 6 years, and we do it every month. What's 12 times 6? 72. So that's how many terms we're trying to add up. That is n. N is 72. Do we know the first term? Yeah, we know a sub 1. A sub 1 is 50. Okay, and then the rate comes from right here. The rate is going to be 1.05. Okay, so let's plug that all in and see what we get. So let me scroll up. So it's going to be the sum of 72 terms, and it's going to be 50 times 1 minus 1.05 to the power of 72. Oh my gosh. And then that's going to be divided by 1 minus 1.05. Okay, so I'm going to throw in the extra parentheses just to be on the safe side. You have to have the ones on the bottom, but the green ones in the top you probably don't have to have. Okay, so let me clear that out. Parenthesis 50, parenthesis 1 minus 1.05 to the power of 72, parenthesis, parenthesis, divided by, parenthesis, 1 minus 1.05, parenthesis. Let's see how much money there is. Okay, something went wrong. Okay, I know what went wrong. So I messed up the ratio. It was 0.5%, so that is 0.005. And so I need to change that on everything that I was writing. So it's 1 point. It wasn't 5%, it was 0.5%. That's going to make a huge difference. I was going to make a lot more money. Okay, so let me fix this. I think I fixed it up there. I tried to throw that in. But the ratio then is not going to be that. The ratio is going to be 1.005. Okay, so let me see if I can squeeze in a 0 here. Okay, let's try this again. Okay, so parenthesis 50, parenthesis 1 minus 1.005 to the exponent of 72, parenthesis, parenthesis. Yeah, I got enough zeros in this time. Divided by, parenthesis, 1, I left out a 0 there, 1 minus 1.005. Let's see if this works out better. Okay, that looks better. So this is going to be, we're going to go to the nearest penny, 4320.44. Okay, so that's how much money's in the account then after the 6 years. They put in $50 every month, and at the end of 6 years, they had $4,320.44. Now, the question is, how much interest did they earn? Well, if you just put in $50 a month for 72 months, how much is that? 72 times 50. Okay, that's 3,600. Okay, so what's the difference then? So if you want to know just how much interest you made, so you made in the 6 years, you made $720.44. Okay, but it was a good way to save money for the college. Probably not enough though.